Alright, class, so the goal for you is for you to be able to find the surface area of cylinders. Alright? Now, I got a picture of a cylinder right here. Here are the bases, right? Both the same. Alright, but here's a description, a pretty good definition of what a cylinder really is. Alright, it's a three-dimensional object that has parallel bases that are congruent circles. Alright, so those two circles are exactly the same size, same shape. The face that connects the circles, this is the most important part of understanding what a cylinder really is. The face that connects the circles, that's this right here, this face, is that it's just a rectangle. Alright, wrapped around the edges of those two circles. Alright, that's just a rectangle wrapped around the edges of those two circles. Alright, now I'm going to show you why that is. So this is why the face connecting the two circles is really a rectangle. Alright, so you look here, class, we got our cylinder, right? We got our orange circle on top, the orange circle on bottom that we can't see, and we got this green rectangle that's been wrapped around the two circles. So, to kind of show you how this works, if I were to take the tops off, right, I would just have this, well, messed that up, cylindrical, alright, figure, but it would be open on the top and bottom after I remove the caps. Then we start to unravel it. Alright, we start to separate it. Now you can see as we do that, alright, it starts to spread apart. And voila, there we are. We've got our two circles, which right now they look like ovals because, alright, you're looking at them at angles. Alright, but then we've got our rectangle, which, as you can see, class, as we unwrap it, that's really what that face becomes. That dimension, it ends up becoming a rectangle. Alright, so really a cylinder, and you should know this from the 3D models that you made, right before break. A cylinder is made up of two circles and a rectangle. Okay? Now I want you to put a star next to this and write this down. Label this dimension, alright, as the height of the cylinder. Because as you can see, as you go down the line, this dimension right here is really the height of the cylinder. This side of the rectangle is really the height of the cylinder. So put a star next to this and write this down. This dimension, and draw an arrow, alright, labeling it. This dimension is really the height of the cylinder. This dimension is the height of the cylinder. This side. This is the most important part about understanding how to find the surface area of a cylinder. This side right here, alright, that is found, because you're not just going to be given that distance. This is found by finding the circumference of either the circle on top or bottom. Because remember, class, circumference, that's the distance around a circle. So really, this top edge, this edge right here, from one point all the way around the circle to the next, that distance is found by finding the circumference of a circle. So, draw an arrow to this side length, this dimension, and write that this side is found by solving for the circumference of the circle. Draw an arrow to this side length, put a star next to this and write this down. This dimension is found by finding the circumference of this circle. Alright? And I'll show you an actual 3D model, alright, in class. Anyway, now, moving on to how to actually find the surface area of a cylinder. Alright, so I got a cylinder right here, right? Just looks like a can. That's really all a cylinder is, just a can, right? Because I know you're really familiar with cans. Let's say that our cylinder is 10 centimeters tall. Alright, and the radius, we'll say, is 4 centimeters. Alright, well, we have to find the surface area. So we got to find the areas of this circle, and the rectangle that wraps around it. Well, the nice thing about this is the two areas of the circles are exactly the same because the circles are the same size and shape. So to find the area of a circle, remember you have to use your formula, pi times radius squared. Well, pi is 3.14 and the radius is 4. When you square 4, right, that's 4 times 4, which is going to give you 16. And 16 times 3.14 is going to give you 50.24 square centimeters. Alright, and the bottom, that area of this circle, is exactly the same as the area of the top. So everything's exactly the same. 50.24 square centimeters for the bottom also. Now, this is where it gets a little tricky. This side, the area of this side, right, that rectangle that wraps around those circles. Well, rectangle, the area is length times width. Well, the width, we could just say, is this dimension of the rectangle, right? The height of the cylinder. The length, now this is the tricky part. The length of our rectangle is found by finding the circumference of the circle. Alright? So, what we really need to do to find the area of that rectangle is do length times width. Well, in this case, the length is the circumference of the circle. Remember the formula to find the area, or sorry, to find the circumference of a circle? It's pi times diameter. So instead of length times width, it's pi times diameter times the width. Well, the diameter of the circle is 8, because if the radius is 4, right, the diameter is twice that, so 8. And when you multiply 8 times pi, which is 3.14, and then multiply that value by 10, you're going to get 251.2 square centimeters. So this right here is the area of that rectangle that wraps around those two circles, so that we can make our cylinder. But now, for our last step, we have to add up the areas of all the faces. The circle, and this face, the rectangle. When we add them up, we get 351.68 square centimeters. Alright, that's what you need to do in order to find the surface area of a cylinder. And in the next slide, we're going to do the exact same thing. Alright? Lastly, alright, I got a cylinder on its side. Kind of looks like a Tootsie Roll, but I used purple instead of brown, and I didn't color it in. So anyway, alright, we got this tube, this cylinder. Well, the diameter, I'm telling you the diameter now, not the radius. The diameter is 2 yards. The distance from one circle to the next, alright, is 11 yards. So, again, class, remember, you can flip a 3D object any way you want. So, I mean, even if you stand this cylinder up so that the circle's on bottom, then you'll have a circle on top, and you'll have that face, that rectangle that wraps around it. Alright? But in this case, we got the cylinder laying on its side. Well, the area of the front, that circle, is pi times radius squared. Well, the radius is half the diameter. So if the diameter is 2 yards, the radius is 1 yard. So we're going to plug in 1 for r, and pi is just 3.14. 1 squared is just 1 times 1, which is 1. And 1 times 3.14 is 3.14. So the area of that front circle is 3.14 square yards. The area of the back circle is 3.14 square yards also, because those circles are congruent, right? So, the last step, finding the area of that side. Well, like I said before, the width is just the distance from one circle to the next. Alright? And the length is really the circumference around one of the circles. So, we got to take pi times the diameter, which is the length of the rectangle, multiply that by the width to get our area. Well, pi is 3.14 and the diameter is 2. The width, that's the distance from one circle to the next, which in this case is 11. When we multiply all of those values, you end up getting 69.08 square yards. Alright, so I've got the areas of every single face. The nice thing about cylinders is that there's only 3 faces. 2 circles, and then that one rectangle that wraps around them. So then when you find the surface area, you just add up all the areas, and you wind up with 75.36 square yards. Alright, that's how you find the surface area of a cylinder. Alright, and we got nothing else to write down, so that's it. I will see you all soon. Take it easy.